This screencast is on metals and bonding. Metals can bond by either metallic bonding or with a nonmetal in an ionic bond. In metallic bonding, we're talking about just metals. So, a solid sample of a pure metal will bond by metallic bonding. For example, what if you had all copper atoms, where each of these positive spheres represents a copper nucleus and its inner filled shells of electrons? Then the negatives written outside of the spheres represent the valence electrons pooled together from all of the copper atoms. And so the copper atoms have these loosely held outer valence shell electrons that they pool together into this sea of free flowing electrons that can conduct electric currents. So copper can be pulled into wires to be used to conduct electricity. Now, what if we changed some of these copper atoms to another element like zinc, for example? If we had a mixture of copper and zinc metal atoms, we could make an alloy like brass. So, copper and zinc metal atoms mixed together make an alloy like brass. And those alloys will also, when they have metals mixed, pool together their electrons into this sea of free flowing electrons. And those electrons don't really belong to any one metal ion, they're flowing and they can conduct current, for example. Now, metals can also bond to nonmetals in ionic bonding. So, metallic bonding was metal to metal, metal all by itself or metals with other metals. Ionic bonding is metals with nonmetals. In ionic bonding, metals lose their outer valence electrons to nonmetals to form positively charged ions, and the nonmetals form the negatively charged ions, and they're held together by opposites attract, by just positive to negative. Now, in an ionic bond, that's between a metal and a nonmetal, and those electrons are transferred. The metal atoms lose their electrons. So in this case, we're watching the sodium metal atom lose its outer valence shell electron to the nonmetal chlorine, and the nonmetals gain electrons. And there'll be a strong attraction between positive and negative ions to make the ionic bond. So if we look at sodium, it starts off with 11 protons in its nucleus and it has 11 electrons to begin. That 11th electron is its outermost valence electron that it loses to chlorine. Chlorine starts off with 17 protons and 17 electrons. And chlorine wants to gain that one more electron. Now, when sodium gives up one of its 11 electrons, now it just has 10 electrons. When chlorine gains an electron, it goes from having 17 electrons to 18 electrons. So when we look at the charge, sodium's charge is overall positive because it still has its 11 protons, but now it's down to 10 electrons. So protons outnumber electrons. Chlorine just got one more electron. So now its electrons outnumber protons and it's got a negative charge. If we look at sodium, it fulfills the octet rule because when it gives away that outer valence shell electron, it reveals a filled shell underneath where there are 8 outermost electrons. Chlorine meets the octet rule because it had 7 in its outer valence shell and now it got one more and it's got 8. So they both meet the octet rule at the end of the ionic bonding.